Hello, my name is Muhammad Asadullah and I am a doctoral student at University of Oulu. In this video, I am going to present one of our recent research paper entitled Massive Machine Type Communication and Satellite Integration for the Remote Areas. This paper is accepted for publication in IEEE Wireless Communication magazine. Let's start with the motivation. Despite all the technological advancement, the wireless connectivity for machine applications in remote areas is still a very big challenge. mMTC applications in remote areas can bring several benefits. For example, it can improve the life quality of indigenous people. Smart agriculture solution can enable farming in harsh environments such as deserts. Similarly, mMTC applications in remote areas can offer control and monitoring services for offshore wind farms, offshore transportation, and offshore oil rigs. We opted LoRaWAN, and here are the few points about it. It works on a CSS-based modulation scheme LoRa. It operates on license-free frequency band. Network has star-of-star topology, and end devices use Aloha protocol. The time on air of a packet depends on a specific SF. LoRa signals can be modulated with different SFs, and end devices are not associated to a specific gateway. That is why network has no handover. We consider two different implementation strategies. In an indirect approach, devices will transmit the data to a gateway. Gateway is connected with the modem, and then that modem transfers the data to the satellite. On the other hand, in a direct approach, devices can directly transmit the data to the satellite. And then there are the different options available for the placement of the network and the application servers as shown in the picture. Now let's dive deeper into these implementation strategies. First, I will talk about indirect approach. It has several benefits such as it relies on well-established and proven technologies. The availability of gateway at ground offer options for aggregation and pre-processing, and it makes the radio channel more predictable. It has some downside as well, such as there is a need to create a terrestrial infrastructure. The gateway energy consumption may exceed the overall energy consumption of the devices, and the gateway may become the potential bottleneck for the system reliability and security. Moving toward the direct scheme, devices can directly transmit the data to the gateway at satellite. That makes the network more simple, more homogeneous, and handover free. In terms of downside, gateway will receive a lot of data. The mobility of LEO satellite will cause Doppler shift. The larger connectivity distance will increase the energy consumption and time on air. That's how our system model looks like. It accommodates the mobility of satellite with respect to node, and the distance from a node to satellite depends on the elevation angle. We get the highest distance at the minimum elevation angle, and the receiver at satellite has 48 different spot beams. And here are the key simulation parameters for our scenario. To analyze the performance of direct implementation strategy, we run Monte Carlo simulation for different nodes density. In our numerical result, the term PSNR is the probability when the packets SNR exceed the SF specific threshold, and its value remains higher than 69% for SF7 and more than 98% for SF12, while the term PSIR represents the packet reception probability in presence of interference from the other nodes, and we can see that its value declines by increasing the number of nodes as well as it decreases toward the higher SF. The PS represents the overall success probability, which is the product of PSNR and PSIR, and in our case we achieve the highest success probability for SF10 with 100,000 nodes. Finally, I will talk about open challenges and research direction that includes sensor distribution, modulation coding scheme and transmit power control mechanisms, security and reliability, terrestrial satellite cooperation and resource management, beamforming, legislative and the business aspect related to mMTC and satellite integration. That's all from my side. Thank you for watching the video. If you have any question, you can ask in comments.